Hi, welcome back. This is Rashid. So today I'm going to change the strategy a little bit. In the last couple of videos, I mentioned that I will focus on tickle first, but I'm thinking of I'm going to create a separate tickle series, and that will come within next day or two. So it should not take much time. So this series that I have right now, RTL2 routing, I'm going to focus purely on taking that simple block of counter all the way to routing. Okay, so what we did so far today, I'm going to cover design read step. uh, Yes, so today I'm going to cover design read step, but I am not sure what I covered last time. How much I covered last time. So very first step was library setup. Hopefully that is clear to you and you have tried that in the tool that I'm using. Technology file, I think I did explain that. So very quickly, this is the command that we use. I mentioned and yeah, I mentioned these variables, I think, and then I mentioned NDM files. This is the name you give it. Then the tech file. This is the timing library. This is the timing library. This is the vendor provided library. NDMs are the layout libraries. You cannot see them. Those are binary. Tech file, you can see yourself what is inside tech file. Sorry, I'm moving a little faster, but this typically each layer information is there, like metal, vias, weld, fusion, and for each layer we have what color, what kind of pattern for display, pitch, width, spacing, and all that, and the unit resistance, capacitance for each layer, design rules, some of the basic one. This is not a design rules set, that comes in a separate file. And yeah, I think that's what it was. So today we will focus on design read, little bit of tickle as I go. I will introduce definitely, but the full tickle tutorial will come in a separate series. So design read, so library is set up now. Okay, so now we need to read input design or read RTL, and that is what I'm going to talk about in this one. Keep in mind, this is our design. This is our simple counter. Okay, and I already explained this, but very quickly again, it has clock, it has reset, enable, and scan in, scan out, and scan enable. I kind of put hard coded into RTL. This is the style I'm going to do because it makes a little bit more explicit as opposed to creating those physically later on. But you can see that there is no connection of scan in, scan out. I will do that during the DFT step that you will see. This is a simple counter on a positive edge of the clock. It checks if reset is 1, it counts, reset the count, which is a register. And if enable is 1, then what happens is then count and incremented by 1. So there is kind of adding by 1 component there, which will have combinational elements. Okay, so that's it about the design. How you are going to read it, I created a sin read design.tickle file. Okay, and here is the small code that I'm using for this. I have only one system verilog file. So as I said, at the beginning of each file, I put some sort of code, tickle code, which tell you what kind of script it is. The benefit is when you have a log file, and if there is any error within that code, using this and this command, I can see, okay, this one is showing, is displaying on your terminal, or if you are redirecting output to a log file, it's going to show in the log file. Okay, begin sourcing info script. This command returns the full path of the file that is being sourced right now. So in my top level flow, I just do source sin underscore read underscore design article, and this file contains these. So when it tool comes in, it sources this one. So it says I'm sourcing this now. Then I'm doing this command. So analyze and elaborate. These are the tool's native commands. These are not my own tickle. Okay. So here is important one. Analyze dash format, since the file I'm using is a system verilog. So this is again a keyword, s verilog. and I'm giving the way the option I've done it, I'm going exact path. So keep in mind, if you go back to the folder structure I created, sorry, I should have copied that. Where is my folder structure? I thought I had somewhere folder structure. If not, I will draw that. So give me a second. So I created some electrical stuff. It looks like I don't know where is that, but here is it. The structure that I have, as I told you, I created my folder. Let's say I call work, whatever date, 12, 26, 24, or now it's 25. So under there I create flow scripts folder. This is underneath, this is one folder. Then I have okay, sorry, this is not work, sorry, I'm really sorry. So create a folder somewhere, like flow training, something like that. Okay, underneath you have flow scripts, underneath you have constraints, underneath you have, these are the folder design, and underneath you have a work. You can have work every day you come, you can create a different work. So let's say it's 0108 January 8th 2025. So right now I am sitting inside. I did a CD, what are their flow training, and then I did a work 0108 2025. So right now my present working directory should be this one. I'm sitting inside that, and I set up the tool. I open the tool with FC shell. Okay, when I got the tool shell, I created a lib, and for that I remember I told you I created a separate file, but basically you have to use create a lib command. You can put that inside another file, which, one second, let me see, it's been a few days since I did last video, so I'm forgetting few things, but I think I did mention that I source a different, oh yeah, this is where, so anyway, I already explained that. I don't know. I thought I told you that I created another file. Okay, yeah, and I think this is it. So look at this. I created a separate file. It called lib setup.article. Okay, and inside lib.article again I put this one, and I created these variable setup, and then I did a create lib like this one, and then I this one. So at the top level I'm just sourcing different files. So source lib setup article, that should have already library created, and after that I am getting into sorry, this one. I'm that. So at the top, my top file, you can call it my flow.article file, which is all my scripts are inside this. So this is where my flow.article is here. Okay, and there is also my lib setup the article is there too, and in there I have syn read design, the article is there. Okay, so when I am sitting in the present working directory here, okay, so all I'm doing is this. Let's bring that. So all I'm inside this one. Okay, inside this file, I have these consent. Source, what was the lib, setup, the article, and then source, this one, syn, read, design, the article. Okay, so you can what you can also do is you can invoke the tool fc shell and then start using these one initially, because you are just do this one first, source this file, then source this file, and later on when all your scripts are working fine, you can put them into this file, so that later on when your flow is created, right, you will just source this thing. Make sense? All right, let's rub this out so that it doesn't let's see them. All right, so going back, what is inside? So analyze, so I have only one system verilog, so and I am inside this one, so I need to go one folder up into design, and that's where I have already copied or created this file, so I'm going to delete that. Okay, and after that I'm going to do elaborate design, and then set top module. Just keep in mind, set in the beginning of very first thing, not inside a file, at the top level that I did create. I wrote a set I created this variable set design name as counter. Okay, because my module here is counter. So when I do this setup module, that top level, here is the output. Okay, and this is a simple one file, so you can see it's not that, but when you're reading a lot of files, it will have a lot more. So let's stop this one here, and what I'll do is in the next video I will start from here, start elaborate explaining what is this and a little bit more things about, okay, when we are done with this, what really happens, what is inside the memory right now. Okay, sounds good. So let's stop it here and jump on to my next video. Thank you so much. Bye.